Hello everyone. Our next topic is acceleration due to gravity. Now, uh, this word, this phrase, acceleration due to gravity, I will just break it up and explain it to you. Okay. So, acceleration can always take place due to a force. So, acceleration due to gravity is the phrase here. So, what makes gravity into? So what is gravity basically? What is gravity? So, gravity is the force due to which acceleration in any body takes place. So, gravity is nothing but a force. So, what force is gravity? Gravity is force of gravitation exerted on any body by earth. Force of gravitation exerted on any body by earth is known as gravity. Okay, so due to this force there definitely will be some acceleration, and that acceleration is acceleration due to gravity. Okay, so what is the symbol for acceleration due to gravity? The symbol for acceleration due to gravity, which we might have studied earlier as well, the symbol of this term acceleration due to gravity, small g. Okay, so we have to study about small g, how to find its formula, what is its uh, formula, what is its SI unit, everything we have to study about small g. Okay, now before we go ahead, because I have explained the meaning of the term gravity, now there is a huge difference between gravitation and gravity. So there is a difference now. Okay, so don't use both the words indiscriminately. Understand the difference between them and then use them. Gravitation is the force between any two objects in the universe. Okay, force between any two objects in the universe is known as gravitation, or you can say phenomena of gravitation. Okay, gravity is, on the other hand, force exerted on any body by earth. Force exerted on any body by earth is known as gravity. So this is the difference between gravity and gravitation. Okay, here we are studying acceleration due to gravity. That means what will be the acceleration produced in a body which is acted upon by the force of gravitation due to earth, or when earth exerts the force of gravitation, that is gravity, on any body, what is the acceleration produced in it? That is what the definition also says here. The acceleration of a body due to attraction of earth towards its center is called acceleration due to gravity. It is represented by small g. Its symbol is small g, remember. Now, how to derive its formula, remember. If we drop a body of mass small m from a height h to the surface of Earth, whose mass is capital M and radius is capital R, its speed will increase as it comes nearer to the surface. You have also seen it. If any object is dropped from a certain height, does its speed remain constant as it reaches the ground? No. Its speed continuously increases. And as it reaches ground, its speed becomes maximum and then it hits the ground. So no body, you can say, can fall with zero acceleration. There is always some acceleration involved. Yeah, if you consider uh, force of friction between the air molecules and the falling body, then there can be some, you can say, some difference in the value of acceleration due to gravity. Yeah, because there is an opposing force of friction which is allowing the body to come or fall slowly. Possible. Like, a feather or a paper, if it falls down to the ground, it falls slowly. That's not due to less acceleration due to gravity produced in it. Acceleration due to gravity produced in it due to the force of attraction of Earth is the same. But due to the opposing force, the net acceleration decreases. Opposing force of friction of air. Right? So we'll study about that later. But generally speaking, any body which is dropped from a height, its speed or velocity goes on increasing and it accelerates as it reaches the ground. Okay. Now let h be a very small distance, okay, compared to the radius of Earth r, and the body is dropped from a height h. The acceleration of the body is the acceleration due to gravity. Now, how we can find the force acting on the body? Force is equal to mass into acceleration. Force produced or force acting on the body is equal to mass of body multiplied by acceleration produced in it. That is small m into small g. F is equal to small m into small g. But this force on the body is due to gravitational pull of Earth or force of gravity. Therefore, we can say that this force produced in the body is equal to G, universal gravitational constant, multiplied by capital M, mass of Earth, multiplied by small m, mass of the body, upon r square. The distance between them, which is equal to the radius of Earth. We have neglected h because it's very small compared to the radius of Earth. We have done that earlier also. So this is nothing but the formula of force exerted due to gravity. That is gmm upon r square. Universal gravitational constant g multiplied by product of the masses upon r square, that is square of the distance between them. Okay, from 1 and 2, F is equal to mg. We know that. See, F is equal to mg. So in the place of F, if we put mg, it's okay. Yes, perfectly. And g m upon r square stays here as it is. Now small m gets cut from both the sides. So we find the value of small g. Small g is gm upon r square. What is g? G is universal gravitational constant. Let me write here. whose value we know. M is capital M is mass of Earth, and R is radius of Earth. Now remember one thing, at any place on the Earth, universal gravitational constant remains the same. Mass of the Earth remains the same. What about the radius of Earth? Will it always remain same at any place on the surface of Earth? The answer is no. Now you may think that Earth is spherical in shape. The Earth is not spherical in shape. The Earth is flattened at curves, at poles, I'm sorry, and curved at the equators. So the shape of the Earth is not like this, what they have shown here, but the shape of the Earth in reality, I will show you. It is somewhat like this. Okay, it is somewhat like this. It is more, you can say, bulged out at the equators. Okay, and it is over here at poles, it is flat and bulged out. So that makes this Earth having different radii at different places. At equator, the radius is maximum. The distance from the center to equator is maximum. And at poles, the radius is minimum. Okay. So on traveling from equator to pole on the surface of Earth, you would encounter different values of acceleration due to gravity exerting on any body when the body falls down. See, now radius of Earth is in denominator. We have square of the radius. Okay, and this radius is maximum at equators. So the value of G will be minimum at equators. You know why G will be minimum at equators, small g? Because at equators the radius is maximum. If the radius is maximum, then this denominator becomes maximum. If the denominator becomes maximum, the value of whole fraction decreases. कोई भी फ्रैक्शन में जब डिनोमिनेटर बड़ा होता है तो पूरे फ्रैक्शन की वैल्यू कम हो जाती है एंड पूरा फ्रैक्शन इज इक्वल टू एक्सेलरेशन ड्यू टू ग्रेविटी व्हिच विल आल्सो डिक्रीज. So acceleration due to gravity will be minimum at equators, and on the contrary we can say that acceleration due to gravity will be maximum at poles. Pole is this point. Here the radius from the center of the circle, the radius is minimum. If the radius is minimum, then the denominator becomes minimum. The value of whole fraction becomes maximum. Because if you decrease the denominator of any fraction, then the value of whole fraction increases. The value of whole fraction increases, and the whole fraction is equal to small g, that is acceleration due to gravity. It will also increase, right? So g will be maximum at the poles and minimum at the equators. So what is the average value of g which we consider? We will talk about that. First, let's find out its actual value. So actual value of G, if you want to find out, just put the universal gravitational constant, mass of the earth, radius of the earth, and you will get 9.8 meter per second square. Okay, this is, you can say, the average value, because this is the average radius, and this, sorry, this is the average mass and this is the average radius. So this is the average value. Okay, it can be little lesser or greater than this at different points on the earth. At poles it will be slightly greater than this, and at equators it will be slightly smaller than this. Okay, but average value which we take in all the questions is 9.8 meter per second square. That is the value of acceleration due to gravity. You see the SI unit, meter per second square, that is also the SI unit of acceleration. Sometimes in some questions the value of G is taken as 10 meter per second square, but that's not a problem. You can take the value of G as 10, that's not a problem. Sometimes it is rounded off and taken as 10. Sometimes it is taken as 9.8. So whatever the question tells you, you just follow the instruction in the question. If the question tells you to take the value of G as 9.8, you take 9.8. If the question asks you to take the value of G as 10, take 10. But if the question does not say anything about the value of G, you should always take this value, because this is mostly given in all the textbook, 9.8 meter per second square. Okay, so this was the value of G for Earth, that is acceleration due to gravity. But acceleration due to any other planet's gravitational pull can also be calculated using this formula. So here we have Gp, that is acceleration due to the gravitational pull of any other planet. Remember, I'm not using the word gravity. Gravity is only used for Earth's gravitational pull. Okay, so for any other planet's gravitational pull, we cannot use the word gravity. Okay, although they might use it in some examples or somewhere in your textbook, but that's not right. Gravity is a specific term which is used for the gravitational pull due to Earth. Okay, so Gp is acceleration due to that planet, which we have to calculate. Mp is mass of the planet, Rp is the radius of the planet. If we put the values, if we know the values, suppose if you know the mass of moon and if you know the radius of moon, and you definitely know the value of universal gravitational constant, then you can plug in the values here and get the value of acceleration due to the planet's gravitational pull on that planet's surface. Now here they are saying the same thing in conclusion 3, that Earth is not a perfect sphere. It is flattened at poles and bulged out at equator. Therefore, radius of equator is greater than the radius of poles, and that's what they are finding. See, there is one very important, the same diagram which I showed you. There is one very important conclusion which they have drawn. For constant mass, acceleration due to gravity is inversely proportional to the square of the radius. That also we have known. Therefore, G at equator is less than G at poles. That's what also I told you. Note that there is approximately a difference of 21 kilometer between the radius of equator and poles. Not a huge difference, very small difference, 21 kilometer, but due to this, the value of acceleration due to gravity changes by a little bit. Okay, but average value we have taken already, 9.8 meter per second square, so you don't have to worry about that. The acceleration due to gravity of a body of mass m on a planet of mass capital M and radius capital R is independent of the mass of the body itself. Now, if you see the formula of acceleration due to gravity, acceleration due to gravity, yeah, this one. Let me show you this formula again. In this formula, we did not notice one thing, or maybe we noticed, but we didn't talk about it. In this formula is regarding the acceleration due to gravity on any body which is falling towards the earth. It has universal gravitational constant g's value, mass of the earth, mass of the earth's value, and radius of the earth's value. Does it have mass of that body which is falling down? No. That means acceleration due to gravity does not depend on the mass of the body falling down. So whether it is a stone falling down or whether it is a feather falling down towards the earth, they will both have same acceleration due to gravity. Now there is a very interesting, you can say, debate that whenever a feather or a stone is dropped from the same height, the stone reaches fast. So it has more acceleration due to gravity. But feather has less acceleration due to gravity, and that is a wrong statement. In case of feather, I already told you, if you want to consider the case of feather, you need to consider the force of friction exerted by the air on it, and due to which the net force on feather decreases and the net acceleration produced in it also decreases, and that's why it falls slowly. But I'm going to show you a video now. In the case of stone and feather, or very heavy body and a feather dropped from a certain height, in vacuum, if you drop them in vacuum, they will both reach the surface of the earth together simultaneously. They will both reach the surface of the earth together. So we'll see that, we'll see a video on that. uh, Feather and stone falling in vacuum. Let's check out the video. So BBC conducted this experiment. Let's see this video.
This is NASA's space, and it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems, and that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel. So this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space.
Yes, that's true, when all the air is pumped out from this particular chamber and a vacuum is created within it, a huge force of atmospheric pressure will try to squeeze or crush this chamber. But it is not able to do that because the walls of this chamber are so thick and so strong that they don't collapse, right? See, we studied about this collapsing tin experiment in previous classes. If you have not studied, you when you study atmospheric pressure in this class 9, you will study about it, that if you uh, if you take a small tin can, okay, and if you empty the tin can and pour a little hot water in it, okay, hot water should be very hot, near boiling point. If you pour hot water in it, and as you pour hot water in it, all the air escapes out because the temperature of the air rises and air escapes out, and it is filled with mostly little bit of water, and you can say more of steam, little bit of water and more of steam. Okay, now what you do is you just sprinkle little cold water from outside, or pour a little cold water on the outside surfaces of the can, and you will see the can will crush itself. It will get crushed by itself. It is not getting crushed by itself. It is actually the cold water which we poured. It converted that steam which was filled inside with it will convert that steam which was filled inside into water, because steam condenses, and as the steam condenses into water, the air was not there. Air was definitely not there because it was just pushed out. But the outside atmospheric pressure becomes more than the inside pressure. Now, inside partial vacuum is created, right? So, this external huge pressure of atmosphere crushes the tin can. But here there is no such problem because the chamber, even though it is partially evacuated or completely evacuated, it will not collapse because it's very strong structure. It is made to withstand that force of atmospheric pressure on its walls. Now see, do you see a huge object, that is a ball and a feather, right? They will be dropped from a height.
Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
You know, Galileo did this experiment. Galileo was an um, Italian physicist or mathematician or astronomer, or you can say a lot of things. He was philosopher, and he did this experiment in Italy on the Leaning Tower of Pisa. It is believed to be said that, and then he concluded that all these things which we are studying about are proposed by Galileo.
They weren't.
Amazing, beautiful, right? So this video I show to all students. Okay, I didn't subscribe to BBC. I will definitely do that. Yes, so I so I want to tell you that I've been telling students to see this video since a very long time, and this is an old video. This is not a new video. Say it is from 2014, and maybe it was shot before that. So I tell all the students to see this video. I show them also at times. Okay, so acceleration due to gravity on a body of mass m on a planet is independent of the mass of the body itself. So whether it is a feather or a stone, it will both will fall at the same time. This means that all bodies shall fall at the same rate. Okay. Next is there is one more small formula which is not important. Okay, this formula is not in your syllabus, so don't be worried, but still understand what it says. As h increases, h means the height of the object from the surface of the earth. That is, if a body is at a higher altitude, then g decreases. The acceleration due to gravity decreases. Have you seen skydivers? Skydivers, they like float. That is also due to air pressure. But the value of g is slightly less at that height. Okay, it means that the value of gh goes on decreasing as we move to higher and higher altitudes. And what if we escape the atmosphere of the earth? We are into space, and the value of g is very small over there. The table below and the graph gives different value of acceleration due to gravity at different altitudes. See, height from the surface of the earth. 0 kilometer. 0 kilometer is sea level. Okay, at sea level, the acceleration due to gravity is 9.8. At 1,000 kilometers above the surface of Earth, the value of G is 7.33. And then 3,000, 5,000, 7,000, it goes on decreasing. And finally becomes 0.13 at 50,000 kilometers from the surface of the Earth. That means you are almost in space. This is the graph relating the values of G and the height from the surface of the Earth. Remember few things. The value of G at the surface of Earth is 9.8 on an average, 9.8 meter per second square on an average. Okay, the value of G decreases with height above the surface of Earth. The value of G decreases with depth also. So it's not only the height. Okay, it's not only the height, it is the depth also. Okay, so we know that Earth is little bit like this. Now, as you go above the surface of Earth, as you go above the surface of Earth, G decreases. G is maximum. G is maximum at the surface. And as you go below the surface of Earth, as the depth increases, G, as the depth increases, G decreases again. G decreases again. Can you imagine that? So G, acceleration due to gravity, is maximum at the surface, decreases as you go above above the height, above the surface of the Earth, and G decreases as you go below the surface of the Earth. And G becomes zero. G is equal to zero at the center of the Earth. Very few people know this. Acceleration due to gravity, and you can say force due to gravity. Since acceleration becomes zero, the force due to gravity also becomes zero at the center of the Earth. See, at if you ask me at what height the acceleration due to gravity becomes zero, and we know that at 50,000 it becomes 0.13. So it would be, more than little bit more than 50,000 kilometer, it will become zero. Force due to gravity will also become zero, and you know that in space stations, the astronauts, they just float around because of this zero gravity. And that same thing happens at the center of Earth as well. Center of Earth has zero gravity. Acceleration due to gravity is zero. Force due to gravity is also zero. Very interesting and important thing to know. The value of G is more at poles and less at equator. We know that. The value of G is zero at the center of the Earth. I just told you that. Remember, the value of G at a point is independent of the mass of the body placed at that point. So G does not depend on the mass of the body. It depends on the mass of the planet and the radius of the planet, and also the distance of that uh, body from the surface of that planet. Okay, so that formula which we did not consider, uh, this is the formula. GH, acceleration due to gravity at a height, is equal to G, acceleration of the body at the surface, multiplied by R upon R plus H the whole square. But this formula is not useful. Okay, it will not be asked to you. This is the formula from class 11th. Okay, first we'll just go through this learning plus some extra information. There is no atmosphere on the moon. This is because gas molecules need a certain amount of force of attraction to be retained on a heavenly body. The force of attraction on the moon is less than the required force due to the small mass of moon. Hence, there is no atmosphere. Hence, no atmosphere can exist on moon because the force due to gravity, the force due to gravitational pull on moon is less. Very important table. the table of differences between acceleration due to gravity and universal gravitational constant. What does this table say? First point, the acceleration of a body when falling freely under the gravitational pull of Earth is known as acceleration due to gravity. Right? If any body is falling freely towards Earth's surface, the acceleration produced in it is known as acceleration due to gravity. In this in this definition, one term is very important: falling freely. Falling freely, uh, it points towards the concept of free fall. Always remember, free fall is a topic which you have, a small topic, but you have this topic, free fall. Free fall is under the influence of gravitational force exerted by Earth only, or you can say the influence under the influence of gravity only. Under the influence of gravity only is free fall. So कोई भी ऑब्जेक्ट को जब तुम नीचे डालते हो, ऑफ कोर्स एयर रेजिस्टेंस होता है, बट उसको अगर निग्लेक्ट करेंगे हम लोग, तो वी कैन से दैट द बॉडी इज फॉलिंग फ्रीली. यू आर जस्ट ड्रॉपिंग इट डाउन, ओके, नॉट थ्रोइंग इट डाउन. ये भी याद रखना बात. बिकॉज थ्रोइंग इट डाउन वुड मीन कि तुम भी फोर्स एक्सर्ट कर रहे हो वो बॉडी के ऊपर. ड्रॉपिंग इज just you are releasing the body. Now the force exerted is only due to gravity, that is gravitational pull of earth. तुमने कोई फोर्स नहीं लगाया, ठीक है, you are not interfering, and that is free fall. So what is universal gravitational constant? This is a kind of a revision happening for you. The gravitational force between the bodies of unit mass, each separated by a unit distance, is known as universal gravitational constant. ये कहाँ से आया ये डेफिनेशन? यू रिमेम्बर, F इज इक्वल टू जी. ये हमने डिराइव किया था. F इज इक्वल टू जी कब होता है? जब दो बॉडीज का मास यूनिट होता है, यूनिट मास, और जब दो बॉडी के बीच का जो डिस्टेंस होता है वो भी यूनिट डिस्टेंस होता है. देन द फोर्स ड्यू टू द ग्रेविटेशनल पुल, the force of gravitational pull is numerically equal to the universal gravitational constant. So universal gravitational constant is equal to the value of that force which exists between two bodies of mass, unit masses, and separated by a unit distance. ठीक है, याद रखना है इसको डेफिनेशन में. The value of g is 9.8 meter per second square near the surface of Earth, and the value of g is 6.67 into 10 raised to minus 11 Newton meter square per kg square everywhere in the universe. It's a universal value, whereas this value changes from place to place on the Earth, above the Earth, below the Earth, and it changes in space, and it is different for different planets as well. It is ever changing value. ठीक है? It is not a constant value. It is just an average value. The value of g is different at different positions. It decreases with height and depth from the surface of Earth, and it is different for different planets. जो अभी मैंने बोला. The value of capital G is universal constant. It remains same everywhere. The value of g is 0 at the center of the Earth, and the value of g is the same at the center of the Earth. 6.67 into 10 raised to minus 11 Newton meter square per kg square. It does not become 0. So these are the points of differences between small g and capital G. They are important. They can be asked, or any question based on this can be asked. Okay, great. We are on solved example, and this is a huge one. Write down the expression for acceleration experienced by a particle on the surface of the moon due to gravitational force on moon. Find the ratio of this acceleration to that experienced by the same particle on the surface of Earth. If the acceleration due to gravity on the Earth is 9.8 meter per second square, what is the acceleration of a particle on Moon's surface? Wow. See, when we are talking about any particle, we are not concerned with the mass of the particle, because acceleration uh, produced in a particle due to the force of attraction, force of gravitational pull, does not depend on its mass. So we are least bothered about the mass of that particle. Any particle would experience a force due to gravitational pull at different places, but the value of that, uh, the value of acceleration produced in that particle due to the force experienced by it does not depend on its mass. So let's find out. We have got some constant values. We have got mass of moon in kg, mass of earth in kg, radius of moon in meters, and radius of earth in meters. Okay, first we have to write down the expression for acceleration experienced by this particle. Okay, so let's write the expression. So acceleration experienced by any body on moon, that is acceleration due to the force of gravitation on moon, is equal to g m upon r square, where m is mass of moon, rm is radius of the moon. So this is the expression. This is the expression. Okay. Find the ratio of this acceleration to that experienced by the same particle on the surface of Earth. So they did not ask what is the acceleration of particle on moon surface. Yeah, they asked. They have asked. So let's find it out, man. 6.67. You have to do a lot of calculations. So please keep your pens and notebooks outside, and I hope you were taking notes of whatever I told you till now. If not, then you should have. Please go back and watch the video again, take notes, and then come to this part. And here also the calculation has to be done by you. Okay, 6.67 into 10 raised to minus 11 multiplied by mass of moon, which is 7.3 into 10 raised to 22, the whole upon radius of the moon square, that is 1.74 multiplied by 10 raised to 6, the whole square. Okay, so this is basically the uh, expression and the values which are put into it for acceleration experienced by any particle on the surface of moon due to its force of attraction. Now let's find its value. 6.67 multiplied by 7.3 multiplied by 10 raised to minus 11 multiplied by 10 raised to 22, the whole upon 1.74 multiplied by 1.74 two times because there is a square, multiplied by 10 raised to 6 raised to 2, which is 10 raised to 12. Okay, so this will become, now see, let's get rid of all the decimal places in these terms. Okay, so in the denominator we have 4 decimal places, and in the numerator we have 3 decimal places, 1 2 3, 1 2 3 4. So we will multiply the numerator and denominator with 10,000 and to get rid of the decimal places. So here in the numerator we will get 667 multiplied by 73 multiplied by, since we have For when we have multiplied with 10,000, 10,000 has 4 zeros, and I have shifted my decimal place 3 places, 2 places here and 1 place here. So I have used up 3 zeros already. I have 1 zero left, so I will write 10 over here. And in the denominator, there is no question. It will be 174 multiplied by 174 multiplied by 10 raised to minus 11 multiplied by 10 raised to minus 12. This plus 12 goes into the numerator, becomes minus 12 multiplied by 10 raised to 22. Okay, so this will be okay. Now it is your time. I will just tell you what will this be. See, 10 raised to minus 11 plus 10 raised to, sorry, 10 raised to minus 11 plus minus 12. These two uh, powers will get added because there is multiplication sign between them. So this will become 10 raised to minus 23 multiplied by 10 raised to 22. So that is 10 raised to minus 1. That's not a problem. Problem is here. So here you cannot do anything more. So I want you to just divide the terms and simplify and get a answer over here. Okay, for that you need to do long calculations. Now you are in class 9th. Please don't tell me you don't know how to divide or multiply. Okay, if you don't know that, you don't deserve to be in class 9. Okay, so please do the multiplication, division, pause the video, do the calculation. If you do the calculation now, it is a practice for you to do the calculation while you do the homework or while you are writing your exam, the test. Okay, same calculation is going to help you get the correct answer. I can show you the technique, but I cannot do calculation for you. So I want you guys to do the calculation, pause the video and do it, and then I will confirm the answer with you. Please pause the video. Okay, I hope you are ready with the answer. Let's see. So the answer here of this whole thing is approximately 16.08. So, and here we have got 10 raised to minus 1. So 16.08 multiplied by 10 raised to minus 1 is 1.608, which is roughly 1.61 meter per second square. 1.61 meter per second square. So we have got the acceleration due to the gravitational pull on moon as 1.61 meter per second square. Now what we have to find? Find the ratio of this acceleration to that experienced by the same particle on the surface of Earth. So we have to find the ratio of acceleration due to gravitational pull on moon to the ratio of acceleration due to gravity that is on Earth, which is 1.61 upon 9.8, which is 161 upon 980. Please do the calculation. Pause the video and do the calculation, please. Very important. Okay, so the answer to this is approximately 0.16, which is 16 by 100, which is, if you bring in lowest terms, which I will try to, 4 fours are 425s are approximately 4 by 25. 4 by 25. Can I further bring it? Uh, can I further bring it down? 4 by 25. It is approximately 1 is to 6 approximate, because we wanted in ratio form. So 4 is to 25 is approximately 1 is to 6. So we can say that yes, because if we look here, mm, yes, if we look here and if we consider just 1.6, if we consider this to be 1.6, it becomes 16 upon 98. Now 16 6 are 96, right? So it is approximately, it comes to 1 is to 6. So the ratio of the acceleration due to gravity on moon and acceleration due to gravity on earth. I'm using the word gravity over here, but it should not be used. But for your understanding, this ratio is approximately equal to 1 is to 6. And the acceleration of a particle on moon's surface is approximately 1.61 meter per second square. All the answers are here. Let's check the answers. Yes, they have done the same calculation, 0.16 they had got, which is uh, okay, we had got 1.61, they are getting 1.57, and the ratio they have got 0.16, which we also got 0.16, the ratio, that is 1 is to 6. But it's okay, it's all right, it's perfectly fine. 1.57 is roughly 1.6 meter per second square, and we got near to that answer, so that is fine. Okay, that's not a huge difference, that's a little difference, which is a calculation difference. So if some student has a question that whether or not we will get marks if our decimals differ by these digits, you will definitely get marks. Okay, and these calculations which you have done, they will definitely get you marks. Okay, and your marks will not cut, so don't worry about it. Next question. Find the weight of an object at a height of 6,400 kilometer above the Earth's surface. The weight of the body at the surface of Earth is 20 Newton and the radius of Earth is 6,400 kilometer. Now here you will use this formula, but this formula is not part of our syllabus, so we are going to skip this question. We are not doing this question. As I told you, this formula is not part of class 9 syllabus. Okay, so let's just skip this question and go ahead. Okay, then there is this exercise. Let's go ahead. Free fall. Let's talk about free fall. A body falling towards the center of Earth under the influence of single force only, which is the gravitational pull of Earth, is said to be a freely falling body, right? Uh, let's understand this. I have talked about this earlier, just a while back, but again, we'll try to understand with the help of textbook terminology. Drop a stone and sheet of paper from balcony of the first floor of a building. Will the two reach the ground simultaneously? No, stone will reach the ground a bit earlier. And why does this happen? This happens due to the air resistance. If the acceleration due to gravity is same for all bodies, then why does a person without a parachute reach the ground earlier than a parachutist when both fall at the same from the same height? See, the same thing, stone and feather. We have seen the video, we know the answer. The answer is quite simple. The acceleration is same on all bodies, only when air is not present. In the above case, we do not experiment we do all the experiments in the presence of air. The difference is because of the air resistance. The air resistance is much more in the case of parachutist as compared to the person. If you create vacuum in an enclosed chamber and then drop a stone and a feather simultaneously, you will find both falling at the same rate. We have already seen that. This is because there is no interaction with air. So note that air resistance due to air depends on surface area and the velocity of the body. We neglect buoyant force during the above discussion. Buoyant force is again the force of buoyancy, which we will learn in the future topics after this. Now, how do equations of motion change for a freely falling body? In case of every freely falling body, the acceleration of the body is nothing but the acceleration due to gravity. So whenever you have problems of free fall, remember that you will take the value of acceleration is equal to acceleration due to gravity. Replace A by G. Replace A by G, and the value of G will be given to you in the question, or you can take it as 9.8 meter per second square for Earth. Okay, so let's see how these equations of motion change. Okay, before that, remember, in the absence of air, all freely falling bodies have the same acceleration, which is equal to g, but air resistance may make the acceleration different. But in all the examples which we are going to see, we are going to neglect air resistance. Okay, remember that. In the case of free fall, air resistance effects due to rotation of Earth and altitude are neglected. That is, air resistance, effects due to rotation of Earth and altitude. These all things have to be neglected in a free fall. Only then you can understand the effect due to gravity. No other force except the gravitational pull of Earth is acting on the body. Therefore, A is equal to G. Acceleration on a body is equal to acceleration due to gravity. Now let's see what happens to the general equations of motion given over here. V is equal to u plus at becomes V is equal to u plus gt. But when u is 0, see, when a body is dropped, its initial velocity is 0. So V is equal to gt is the final equation. So first we replaced a by g, and then when we consider that the body is dropped from rest, the initial velocity is 0, then u became 0 and v is equal to gt was the final changed equation for free fall. S is equal to ut plus half at square becomes h is equal to ut plus half gt square. In the place of s, we wrote h because there is a height involved here. And in the place of a, acceleration, we wrote acceleration due to gravity, g. But since u is 0, when the body is dropped from rest, therefore ut will also become 0 and h will become half gt square. That's the second equation of motion in case of free fall starting from rest. V square is equal to u square plus 2as becomes v square minus u square is equal to 2gh, where u square will also become 0 if the body is dropped from rest. So v square is equal to 2gh is your final equation. Activity 2. Throw a stone vertically upwards and observe this motion. What do you observe? You will find that the speed of the stone decreases because it is going against the force due to gravity. So its acceleration will be negative. It will be retardation, right? It reaches a certain height, stops momentarily, and then starts falling freely backwards, back to the ground. As it falls down, its speed goes on increasing continuously. And why does this happen? This is due to the force of attraction by the earth towards the earth, the force exerted on the body by the earth, which produces acceleration in it. Okay, problem solving tactics. Okay, because we are going to start with some numericals, we have to read this. The equations of motion for freely falling bodies are applicable only when g has a constant value. This means the free fall takes place near the surface of Earth. So we have to consider all the problems given to us are near the surface of the Earth, and we can easily apply the changed equations of motion. I hope you have written the new equations of motion. See, even if you forget these new equations of motion for free fall, doesn't matter. We can derive them instantly for any problem. And I'm going to show you how we do that. If height of a body is comparable to the radius of Earth, that is if a height is too high, then value of G will change appreciably. In such case, the above equations are not valid. Okay. So we are not going to consider such cases. For upward movement, the speed of the body decreases, that the body is retarding. Therefore, acceleration due to gravity will be taken as negative minus 9.8 meter per second square. For downward movement, the speed of the body increases. That is, the body is accelerating. Therefore, the acceleration due to gravity has to be taken as positive, plus 9.8 meter per second square. When we throw, when a body is thrown up, the velocity at the highest point is zero. Okay, the velocity is at the highest point is zero. Misconcept. This is also important. Misconcept is when a body is thrown up, the acceleration due to gravity at the topmost point is zero because the velocity becomes zero. No, acceleration due to gravity does not become zero. Acceleration due to gravity is the same, 9.8 meter per second square in the downward direction. When the body is thrown up, acceleration due to gravity is directed upwards because the body is moving upward. No, the acceleration due to gravity always is directed downward, always downwards, and its value never becomes zero at any point. The acceleration concept, the actual reality is the acceleration due to gravity is always directed downwards towards the center of Earth for a freely falling body, and it never becomes zero at any point of the motion of a freely falling body. Let's do some examples and let's uh, you know make our concepts more clear. A particle is thrown up with vertically with a velocity of 50 meter per second. So initial velocity is 50 meter per second. What will be its velocity at the highest point of its journey? What will be the velocity at the highest point of the journey? Okay, it is thrown up, and we have to find its velocity at the highest point of its journey. So v at highest point. Okay, we can find that orally. How high would the particle rise? Height. What time would it take to reach the highest point? Time. Okay. So here, have they given the value of acceleration due to gravity? No. You can take it as 9.8 meter per second square. Please note down the numericals with me. Okay. Pause the video if you need in between. To do the calculation, you need to pause the video. Okay. You have to do the calculation. So be ready for that. Okay. The first thing which we know already, that कोई भी body को जब हम ऊपर फेंकते हैं, तो at highest point what velocity does it have? जब वो ऊपर पहुंचता है तो momentarily it stops. So the highest point velocity becomes zero. So velocity at highest point, that is final velocity, is equal to 0 meter per second. It's equal to 0 meter per second. Initial velocity is 50 meter per second. Velocity at highest point is 0 meter per second. Okay. How high would the particle rise? We don't know that, right? So we can use this formula. S is equal to ut plus half at square. Do we know the acceleration due to gravity? Yes. Do we know the time? No, we don't know the time, so we cannot use that formula. Let's use this formula. V square minus u square is equal to 2as. In the place of 2as, we will write 2gh. Okay, what is v square? It is 0. V is 0, so v square becomes 0 minus u square, which is 50 square, is equal to 2 multiplied by g. Now remember, the particle is thrown vertically upward. That means the acceleration due to gravity's direction is now downward. So the body will be retarded, right? So the acceleration due to gravity will become negative, minus 9.8. 2 into minus 9.8 multiplied by h, that is the maximum height which it will reach. So this will be minus 2500 equals to 2 into minus 9.8 into h. Okay, so minus minus sign just cut it. So 2500 divided by 2 divided by 9.8 will be equal to h. So h will be equal to, that is the maximum height reached by this particle when it is thrown vertically upwards, is 2500 divided by. Okay, so what you can do is you can simplify this over here itself. You can divide this 2 with 2500, you get 1250, and then you can write it as 12500 upon 98. I just got rid of the decimal place. Okay, so maximum height reached. Please find out, do the calculation and find out. Please don't use calculator, because you will not be allowed to use calculator in exams. Otherwise, I don't have any issues. You use calculator, you don't use calculator, but in exams it's not allowed, so don't use it. Okay, so I hope you have got the correct answer. It is approximately 127.5 meter. So this is the maximum height. See the first answer, what will be its velocity at the highest point of the journey? 0 meter per second. How high would it rise? 127.5. What time would it take to reach the highest point? So let's use V is equal to U plus AT. That's the first equation of motion, right? So in this equation, I'm going to write it as V is equal to U plus GT, correct? In the place of A, I just wrote G. Now, what is the value of V? Final velocity, 0. What is the value of U? Initial velocity, 50. Plus, what is the value of G? That is acceleration due to gravity. It is 9.8. Multiplied by what is the value of T? That is the time. We don't know. Okay, one more thing over here. When the body is thrown up, the acceleration due to gravity is negative. Okay, so this will become minus 50 is equal to minus 9.8 multiplied by t. Minus minus gets cut. So 50 divided by 9.8 is equal to t. Therefore, t is equal to 500 divided by 98. You will get the time in decimals. Please find out the answer, divide and find out. Pause the video, divide and find out. So the time comes to be approximately 5.1 seconds. So the body will take 5.1 seconds to reach the maximum height, and the maximum height will be 127.5 meter, and the velocity at that highest point will be 0 meter per second. Let's check the answer. 127.5, 5.1 second, and final velocity will be 0. Correct. With reference to, okay, this question is with reference to the previous question. With reference to the above sample problem, write the time of the particle which it takes from the highest point back to the initial point. See, no need to do the calculation. If you want to do, you can do. Okay, so but now what we are doing is, Now we are considering that the body is now falling down from its highest point. So initial velocity here will be taken as 0. Why? Because the body is now momentarily at rest and then it begins its free fall. And we know how high it came, 127.5 meters. So that is the height it has to cover. But the acceleration due to gravity will become positive, 9.8, because now the body is moving in the direction in which the acceleration is taking place. The force is applied, force due to gravity. That's why acceleration due to gravity is positive. We have to find the time. Now, how much time did the body take to go up? 5.1 second, right? So how much time it will take to come down? If you calculate, you will find it equal to 5.1 seconds. The time will be same. Okay, final find the velocity with which the particle reaches the initial point. Now this I don't know, but I can guess that the velocity with which the particle was thrown will be the velocity with which the particle will reach down. So the final velocity will be approximately equal to 50 meter per second. You remember that was the velocity with which this particle was thrown up. So I think it should be 50 meter per second. But if you don't want to guess both these things, you can use these informations, U, S, A or G, whatever it is, and you can find the value of T, that is your time, uh, using the formula S is equal to UT plus half AT square. And see, S is equal to UT plus half AT square will become H is equal to UT plus half GT square. Now U is 0, so the whole thing is going to become 0. So H is equal to half GT square. Now this is going to be the height. This is going to be the height. So here we put the value of G, here we put the value of time, and we get the height. Okay. So height comes out to be, I'm sorry. We have the height already and we have the value of G already. We have to find the time, so we can find it with the same equation. For finding V, that is final velocity, V is equal to U plus GT. In the place of A, I just put G, right? Put the value of U as 0 and you already have G and T found. Here you have G and you have found T over here, so you can find the value of V. Let's check what is the answer. If you want, you can do the calculation. Pause the video, do the calculation, and then we will check. If not, then let's check directly. I think time is 5.1. Yes, and velocity is 50 meter per second. That is absolutely correct. So remember one thing. Remember one thing very important. The time of rise of any body when it is thrown up, it is equal to the time of fall at which uh, the time with which it will fall down, in which it will fall down. The velocity of throw, the velocity with which the body is thrown, is equal to the velocity of return. The velocity at the lowest point, the maximum velocity at the lowest point when it will return before touching the ground, will be equal to the maximum velocity with which it was thrown up. Right? So very important conclusion. Next question. A ball is dropped from the top of a tower 40-meter high. Okay. So the height of the tower is 40 meter. So a ball is dropped from a height 40 meter. Take G. See, I've already seen that. Okay. What is its velocity when it has covered 20 meter? Oh, amazing question, man. What is its velocity at the height 20 meter? Can you tell me what is the initial velocity over here? It is just dropped, right? So initial velocity will be 0 meter per second. So we know the initial velocity. We know the total height, but that has nothing to do because we have to find the velocity after covering 20 meter. And we know g. Okay, okay, okay. How do we do that now? Oh, yes, we know the height also 20 meters. So uh, we cannot use the first equation because we don't know the time. But we can use the second equation of motion. S is equal to ut plus half at square. Now this would become, since u is 0, I can directly write it as h is equal to half gt square. See how I derived it? No need to remember that इक्वेशन ऑफ फ्री फॉल. यू कैन जस्ट अप्लाई कॉमन सेंस कि अगर u जीरो है तो ut पूरा जीरो हो जाएगा, उसको हटाओ, हाफ a की जगह g डाल दो, t स्क्वायर हो गया, s की जगह h डाल दो. ठीक है, सो h इज इक्वल टू, सी वी हैव टू फाइंड द फाइनल वेलोसिटी एट 20 मीटर. ओके, so what will be h? H will be 20, because see the tower is 40-meter high, and when the body has covered 20 meter, it has fall down 20 meter, it is at a height of 20 meter from the ground. So don't make mistake here. The body was here and this was the ground. In between the distance was how much? 40 meter. So if the body drops down by half a distance, that is 20 meter, 20 meter, if it drops down by 20 meter, how much more distance it has to cover? 20 meter, right? So this is the height of this body from the ground at the considered position. Okay, so 20 is equal to half multiplied by g, that is 10 into t square. Okay, so 20 multiplied by 2 upon 10 is equal to t square. So t square is equal to 4. So t is equal to 2 seconds. So it will take 2 seconds for body to reach this position. But we don't have to find the time. We have to find the velocity. So let's use the first equation of motion. V is equal to u plus at. This equation will now transform into V is equal to gt. Why? Because u is 0, initial velocity. A becomes g and t we know. So V is equal to 10 multiplied by 2, which is 20 meter per second. The velocity when it is at a height of 20 meter will be 20 meter per second. Wait. I did not read the second question. How is that possible? What would be its velocity when it hits the ground? Okay, so this velocity is V1. This is the velocity at the height of 20 meter. This is V1. What is the velocity when it reaches or hits the ground? We can again use the same formula. V is equal to gt. But do we know time? We don't know time, no? So we cannot use this formula. So which formula we use? See, we know the total height and we know the initial velocity, we know the acceleration, and we know the final velocity. No, we don't know the final velocity. We know the initial velocity. Initial velocity is 0, right? We know the height by which it is falling, 40 meter. We know the acceleration due to gravity, 10 meter per second square. We know the final velocity, which is final velocity is 0 meter per second. Hey, we don't know the final velocity. We have to find the final velocity. So final velocity is to be found out. Now u, this is u, okay? U, H, G, and V. How do these connect? Okay, so we have the third equation of motion. I think we can use it. V square is equal to U square plus 2AS, and this converts into V square is equal to 2GH. We have G and H? Yes. So V square is equal to 2 multiplied by G is 10 multiplied by H is 40. So V square is equal to this is 400 multiplied by 2, that is 800. Therefore, V is equal to root of 800. That is root of 800, that is uh, 400 multiplied by 2, or 20 root 2. That is 20 into 1.414. Root 2's value is 1.414. So 14.4 into 2, 28.28 meter per second. Without equation, though, you don't even think about doing anything. Okay. So 28.28 meter per second, that is the velocity when it hits the ground. So some people might say that when it hits the ground, why the velocity is not zero? It is not the velocity after it has hit the ground, but the velocity with which it hits the ground. That is the right way of saying it. Or velocity just before it hits the ground is 28.28 meter per second. The final velocity. Let's check the answer. First answer is 20 meter per second, then the next is 28.28. Perfect, perfect, perfect. Okay, so both the answers are correct, and our method is also good. Now we have understood how to deal with the problems of free fall. Okay, so this problem is for you. I'm not going to do this problem. An object is released from a height. I can just help you with what is given, and you have to do it. An object is released from a height, so initial velocity will be 0 meter per second. Okay, from a height, what is the height? We don't know. Find its speed at 1 second. Okay, so time is 1 second, and we have to find v1, speed after 1 second. Then we have to find v2, speed after 2 seconds, v3, speed after 3 seconds. Okay, then we also have to find the distance traveled in 1 second, s1 and s2 and s3. Okay, what is the acceleration due to gravity? Let me check. No, it's not given. So you can take the acceleration due to gravity as, let's say, I'll make your job easier, 10 meter per second square. Okay, so we know the time. See, time is equal to 1 second, time is equal to 2 second, and time is equal to 3 second respectively, at which we are finding the velocity and the displacements. Okay, so time we know 1, 2, and 3 seconds. Okay, now what? Now you know the initial velocity, you know the time, you know the acceleration due to gravity. You have to find velocities at these time intervals and displacements at these time intervals. Okay, so how you will find velocity? So you can use the formula v is equal to u plus at. You know that u is 0. So v is equal to gt. You know this. Now g is acceleration due to gravity, which is 10 meter per second square, and t is 1 second. So if you put the different values of t, you would get the velocities. Okay, so and how you will find the displacement? Now I have made it very easy for you for velocities. How you will find displacement? For displacement, since you have got the velocity, uh, and you don't know the height, right? You have to find the height. So s is equal to ut plus half at square. Yes, I think that would be useful. S is equal to ut plus half at square. Now u is 0. So this converts into s is equal to half gt square. F is equal to half gt square. Directly into s is equal to half gt square. We know the time, we know the we know the acceleration due to gravity. So we can find the displacement at the end of 1 second, taking time 1, at the end of 2 second and 3 seconds. So we can find the velocities by using v is equal to gt, and we can find the displacement using s is equal to half gt square, because we know the value of g and t respectively. So please do that, and then we'll check the answer. Pause the video and do this. Done. Let's check the answer. So the velocity at the end of 1 second is 9.8 meter per second square. See, they have taken g as 9.8. You would have got it as 10. So don't worry, okay? The velocity at the end of 2 seconds should be for you 20 meter per second, and velocity at the end of 3 seconds for you should be 30 meter per second. Whereas the distance covered by you should be equal to 5 meter here, and at the end of 2 seconds it should be distance covered should be around 20 meter for you, and at the end of 3 seconds it should be 3 square multiplied by 10, that is so 45 meter for you, right? So 5 meter, 20 meter and 45 meter should be the displacement. 10 meter, 20 meter and 10 meter per second, 20 meter per second and 30 meter per second should be the velocities for you. So since they have taken G as 9.8, they are getting different answers, but they have not mentioned what you have to take G as. Just for making your calculation easier, I have advised you to take G as 10 meter per second. Okay, so you can take it as 9.8 also, and you can get the correct answer, no problem. But now you know the method, and now you know how to apply the formula for free fall. Okay, so this is the final topic of this small topic of yours, which was given in your textbook as a very tiny topic of, and I'm sure the teacher would have finished this whole topic in 15-20 minutes. But as you can see, if you want to understand everything properly, and if you want to actually develop your interest in physics, and if you want to think regarding the future, then you have to study this topic in this much detail. So this is the last small topic of the uh, chapter gravitation, and this is also very very important. Now I have this video which I'm making right now is more than 1 hour 30 minutes right now, and I have covered everything, all the details, all the, you can say, theory part as well as numerical part. In the previous video, which was around an hour long, I had covered the basic introduction to gravitation. So I will spend nearly 3 hours on this topic. And see, this is just an example. This is part E in some people's textbook. In ICSE textbook, in CBSE textbook, it is just a small part in NCRT textbook. But the way I'm teaching, I'm elaborating it to a greater extent, and it took me around 3 hours to completely finish it. So when I'm doing this, and when I'm being asked to follow the curriculum or the syllabus with the speed in lockdown which is suggested by school, I feel that it is completely pointless. If I don't teach you in detail, you definitely will be having issues in future. So this is going to be my approach, and it is already midterm, and students who are not comfortable with me teaching in detail, they are free to leave banyan tree right now. Okay, because this is already half term over, and now if you say that you are not comfortable with my teaching pattern, it would be very hurtful to me. So if you think that I should go fast just like school, I cannot do that, and if you want that from me, I cannot give you that. So it's better that it is time for you to leave. But if you're comfortable with me, and if your concepts are getting cleared, and if you're actually concerned about your concepts, then we can definitely continue. And remember that this is half term, and we have completed only 3 chapters of, for ICSE I'm talking, 3 chapters of physics, and there are still you can say eight more chapters left. But if I compare the content of first 3 chapter with the remaining chapters, the first 3 chapters were really heavy, very very heavy, and it has got so much of stuff, so much of concept filled in it, that it takes time for covering. But now the chapters which you are going to face are not going to be so lengthy. They will be small, they will be short. Specifically the last 3 chapters are very small. For CBSE, there is not an issue because the speed has been really, we are mostly ahead of your school, and they are not going in great speed. So I think they are more considerate, CBSE schools, and they have the same topics, but still they are more considerate, and their syllabus is still better, you can say. But CBSE also has got now with me, CBSE after this chapter, after this topic, has got more three chapters to cover, and that will be done very easily. For ICSE, it will take some time, but the chapters will be smaller now. So don't worry. Let's finish this and let's call it a day over here. So our next topic is mass and weight, which is a very you can say troubling terms for all of you till now. Mass and weight. What is mass and what is weight? Let's try to understand it. First, mass. Mass is the quantity of matter contained in the body. Quantity of matter contained in the body is mass. Mass is the fundamental property of material body. Every material body which has got particles in it will have mass. Mass of a body does not change with place. These are all important points about mass. Mass is the quantity of matter contained in the body. Mass is the fundamental property of material body. Mass of a body does not change with place. This means that a body having a mass of 4 kg will have the same mass on Earth or on Moon or in a satellite or at any other place. अगर बॉडी का मास 4 kg है तो वो यूनिवर्स में कहीं भी जाए उसका मास 4 kg रहेगा. ठीक है. मास इज अ स्केलर क्वांटिटी. रिमेंबर, this means that mass can be added by normal algebraic rules. It has no direction with it, it has only magnitude. Mass can be calculated by the following two methods. पहले तो if we know the formula F is equal to m into a, then if acceleration is 1, then mass is equal to the force uh, of attraction. So mass of the body is the force required to bring a unit acceleration into it. If more force is required, the body has more mass and vice versa. तो अगर किसी भी बॉडी में यूनिट एक्सेलरेशन प्रोड्यूस करना है तुम्हें, तो उस पर जितना फोर्स लगाना पड़ेगा वही उसका मास होता है. मास इज मेजर्ड बाय फिजिकल बैलेंस. दिस इज द फिजिकल बैलेंस विच यू सी ओवर हियर. ये तुमने कहाँ पे देखा है? ज्वेलर के शॉप में देखा है. यही फिजिकल बैलेंस है. ठीक है. और तुमने कहाँ पे देखा है? ये फ्रूट और वेजिटेबल वेंडर्स के पास देखा है. बीम बैलेंस होता है. ये फिजिकल बैलेंस से ज्यादा एक्यूरेट है बीम बैलेंस से, बट दोनों का फंक्शनिंग सेम है. और एक ये भी होता है डिजिटल फिजिकल बैलेंस, जहां पे ऐसा स्केल होता है, इस पे तुम्हें मास दिखता है. अ पैन बैलेंस is an instrument used in grocer's shop. They all measure mass. What is weight? Weight of a body. Weight of a body is the force with which the earth attracts the body. तो हम लोग हमेशा बोलते तेरा वेट कितना है, मेरा वेट कितना है. ये जो वेट है ना, weight is actually the force with which the earth is attracting or your body. और एक तो हम बोलते हैं कि मेरा वेट 50 kg है. ये इतना बड़ा गलत स्टेटमेंट बोलते हैं हम लोग इन द कंटेक्स्ट ऑफ फिजिक्स. ठीक है. फिजिक्स में व्हेन यू आर टॉकिंग अबाउट weight, weight should be always measured in newtons and mass is measured in kilograms. ठीक है. ये जो मास है ना, इसका ऐसा यूनिट किलोग्राम है. लेट मी राइट इट ओवर हियर. हमने कैसे ढूंढना है मास, वो तो पता लगा लिया. SI unit of mass is kilograms. Remember that. ठीक है. वेट क्या है? देखो, वेट इज द फोर्स विथ विच द अर्थ अट्रैक्ट्स एनी बॉडी. तो फोर्स ऑफ ग्रेविटी क्या होता है? मास इनटू एक्सेलरेशन. सो वेट इज मास इनटू एक्सेलरेशन. वेट का फॉर्मूला हो गया ये m into g. Weight is not fundamental property of a body because it depends on g. If the value of g changes, then weight also changes. और g तो हमें पता है जीरो भी हो सकता है. स्पेस में g जीरो हो जाता है, तो स्पेस में वेट जीरो होता है. तो स्पेस में यू फील वेटलेसनेस. वेटलेसनेस मतलब वेट फील नहीं होता है, इसलिए लोग फ्लोट करते हैं. वेट इज मेजर्ड बट स्पेस में मास होता है. ठीक है. जी जीरो होने की वजह से वेट जीरो हो जाता है. वेट इज मेजर्ड बाय अ स्प्रिंग बैलेंस which measures the pull in the body by Earth. Let us consider two cases to understand this. Let us consider two cases to understand this. Number one, the body is on moon. How can we find the acceleration due to gravity on moon? हमने पहले भी ढूंढा था by using the formula gm is equal to universal gravitational constant multiplied by mass of moon multiplied by upon the square of the radius of moon. So mass of moon we know, radius of moon we know. So acceleration we found earlier also as 1.6 meter per second square. Now we know that uh, acceleration due to gravity on moon is 1/6 the acceleration due to gravity on earth. तो weight on moon कितना हो जाएगा? Weight on moon will be mass multiplied by gravitational acceleration due to gravity on moon, which is mass multiplied by acceleration due to gravity on earth divided by 6. That is weight of the body on earth divided by 6. मतलब weight on moon is 1/6 the weight of a body on earth. मतलब किसी बॉडी का वेट अगर लेट्स से 60 न्यूटन है, तो मून पे उस अर्थ पे 60 न्यूटन है किसी बॉडी का वेट, तो मून पे उसी बॉडी का वेट डिवाइड बाय 6 10 न्यूटन हो जाएगा. बट मास चेंज नहीं होगा, वेट चेंज होगा. ठीक है. अगर बॉडी सेंटर ऑफ अर्थ पे है तो क्या होगा? जी की वैल्यू सेंटर ऑफ अर्थ पे कितनी होती है? जीरो. Therefore, the weight of that body at the center of earth will also become zero. So at the center of earth, the body will feel weightless, and in this space the body will feel weightless. So conclusion is that as the height of the body from the surface of earth increases, the weight decreases. Also, as the body goes inside the earth near the center, the weight decreases. From the above discussion, it is clear that weight of the body changes with change in the value of acceleration due to gravity. In spaceships moving in space, persons experience weightlessness. Have you seen this? There are many videos on YouTube, you can see. As the apparent value of G is zero. Similarly, persons jumping from a helicopter before opening a parachute experiences weightlessness. जो लोग फ्री डाइविंग करते हैं, क्या बोलते हैं उसको, बेस जंप करते हैं, फ्री डाइविंग करते हैं, दे ऑल्सो एक्सपीरियंस वेटलेसनेस. Weight is a vector quantity. It means that weight has a sense of direction. It is always directed towards the center of Earth. Weight is measured by spring balance. Remember that. Weight is measured by spring balance and mass is measured by physical balance. The SI unit of weight is Newton. So let us now summarize the points of comparison between mass and weight, जो बहुत important है. पूरी summary इसमें आ जाती है और इसके ऊपर questions भी आते हैं. Mass is the quantity of matter contained in a body. Weight of a body on the earth is the force with which the earth attracts a body. ठीक है? Then mass is a scalar quantity, weight is a vector quantity. दोनों की definition हो गई, फिर scalar vector हो गया. SI unit of mass is kilogram and the SI unit of weight is Newton because it is a force. Mass of a body is fundamental property and does not change, remains same everywhere. Weight is not fundamental property of a body, depends on the acceleration due to gravity, and it has different values at different places. Mass is measured in a pan balance and weight is measured using a spring balance. So these are the points of differences. 5 points of differences, all are important. Okay, we'll take one solved example and we are done with it. Weight of a girl is 294 Newton. Find her mass. So weight is equal to 294 Newton. We have to find the mass. So W is equal to M into G. So 294 is equal to M multiplied by G. Let's take it as 9.8. So mass is equal to 294 divided by 99.8. That is 2940 divided by 98. Please do the calculation and find the mass in kilograms. Pause the video and do the calculation. Okay, done. Let's see. It is 30 kg. The answer is 30 kg. Okay, so yeah, the next question is not from your syllabus, so don't do that. Okay, the part, this whole gravitational part is over, as I told you. So you will do the respective exercises, and I will assign you that. And I'm going to see you in the next video. I think next we are doing chemistry after this. Okay, see you later. Bye bye.